That's nice. So you're going to take, I mean, what you're really going to do here, let's actually cheat a little bit. You ready? I'm going to cheat just a tad. I'm going to take this right here, I copy it, and then I'll take this, and we're rotating y-axis or x-axis?
Y.
Take this, I'm going to, let's see, paste another one right there. So I'm going to take this one right here, I'll pause it. Okay, so how many people got that much at least? Get that much at least? Nice, okay. So there it is. So you have to draw the height of each cylindrical shell. So let's draw the height. Let's get some blue here. So let's say that's the blue here. What's the height going to be? H in terms of x. What's the height? Sine of x squared, right, exactly. What's the radius in terms of x going to be? It's just x, right? Because what are you rotating around? The y-axis. So the radius in this case is the distance from x to 0. What's the distance from x to 0? X. Do you always rotate around the x-axis or the y-axis? No, sometimes you have to add or subtract a constant. Just keep that in mind. So I think that's what it asks you to do first. Sketch a cylindrical shell and find its circumference. Use the shell to find the volume. Okay, so when you draw these, draw the mirror, right? Then you can connect like this. You can kind of exaggerate the curvature. That's fine. How am I doing? Am I doing? No, that's not very good, is it? Like this. Like that? That's not bad. I think I did okay. So what was that formula, or what, not formula, but what should the integral be? 2 pi from what to what? 0 to what? Root pi of sine of x squared times what? X dx. Nice. And now can you evaluate that decently easily? Yeah, what do you have to use to integrate this? You have to use u substitution. Bridget, what's the u going to be in this case? Yeah, so you get du is equal to 2x dx. So dx is du over 2x. So we substitute and we get 2 pi of sine of u x times du over. What cancels immediately? Well, the magical thing happens. You love getting rid of those x's right there. And then you bring the 2 out front, the 1/2 out front, it cancels with the 2. So what are you left with? Pi sine of u du. Now, what have I not written in? What have I left out? Why did I leave it blank? Need to change them, exactly, right. So we know u is equal to x squared, so what do they turn into? Instead of 0 to root pi, what does it turn into? 0 to pi, because you square both of those values. So now, can you integrate sine pretty easily? What is the integral of sine? Negative cosine u from 0 to. So you get negative pi of cosine. I just like pulling the negatives up because I'm terrible at remembering the negatives when I evaluate integrals. So what is that going to be? Negative pi. And again, the calibration is off on this, and it's really annoying today. Negative pi of what? Cosine pi minus cosine of 0. What's cosine of pi? Cosine of pi is negative 1 minus what's cosine of 0? 1. So what do you end up with? Negative 2 pi. 2 pi. So does it work? That's a nice answer, right? Did you get it right? Yay, that's great. Okay, what does it ask you to try to do next? It asks you to try to do something next. What was it? Explain why you can't. Why this method is preferable to slicing. When they say slicing, they mean using washers, right? Now, you draw the washer. You can draw the washers, right? Yeah, let's draw the washer. Now, here's your axis, nice. And for the washers, they're parallel to the x-axis, so maybe like right here and right there. So then you have your hole in the middle, like this. Like that, right? Is it dx or dy? dy. So you have pi integral from 0 to something, right? Of big R squared minus little r squared dy. Now you have to find the big radius and the little radius. You also find the question. Let's find the question mark. How do you figure out the question mark? Well, theoretically, you want to know how. Where is question mark on that picture right there? It's the maximum, right? You want to find that maximum right here. Do you agree with that? Right? Okay. So this right here is question mark. Is that an easy thing to find? Okay, let's find it. Let's see what it is. So we know y is equal to sine of x squared. How do you go about finding that maximum value? Find where the derivative is 0, right? So you get y prime is equal to what? 2x times cosine of x squared. Is that something you can, so you want to solve this. 0 is equal to 2x cosine of, what's the trivial answer to that? X is 0. Is that the one we're looking for? No. We need the other one. Is that something that you can just do easily with some trig identity or factoring? What do you think? Yeah, it's not bad actually, because you want to know when cosine of x squared is equal to 0. And that's when cosine of x is equal to 0. When is cosine of x equal to 0? Pi over 2. So you actually have it there. That's not bad. So don't give up too easy. I was about to give up, honestly. So it goes from 0 to pi over 2. So you're chugging along, and that's okay. But now what do you have to figure out? What are we missing? Yes, we're finding, that's what we're trying to determine. But what part of the equation are we missing? What are these? They're right there, kids. The radii. We need the big radius and the... So let's just try to find the big radius and see what happens. The big radius, does it need to be in terms of x or y? It needs to be in terms of y because we're in dy. So we know y is equal to... What do we know y is equal to? Sine of x squared. So what do we need to isolate? No, y is already isolated. We need to isolate the... Because the radius is x distance, but we need it in terms of y. So what do we need to isolate? X. Okay, ready? Here we go. So we have x squared equals sine inverse of what? Y. So x is equal to plus or minus the square root of sine inverse of y. Why is it plus or minus? It's plus or minus because look where the... It should make sense that it's going to have a plus or minus in, because where's the little r? It hits the same function, right? Kind of nasty. Is this something you'd really want to have to do? Not really. The other thing is, do you know what the integral... Let's just ignore the square root for a second. Let's say the square root goes away because we're going to square it, right? So you end up with sine inverse. Do you know what the integral of sine inverse is? No, you know what the... What of sine inverse? You know the derivative of sine inverse. You know that the derivative of sine inverse is what? Do you remember? So what's your first step if you're doing 10 here? Draw a picture. So x equals the square root of y. So x is the square root of y. And you're rotating around y equals 1? Okay. So x equals root y. What does that look like? Oh, you are on the x-axis. Sorry. Those are the boundaries, x equals 0. Oh, okay. So when x is 0, what's y? When x is... Yeah, so we know it goes through the origin, right? So what does it look like? Looks like x squared, right? Does it go up to the right or up to the left, or which way? To the right? Okay. Like this. So x equals the square root of y. Are we okay with that? So x equals 0 and y equals 1. So we're bounding this, right? X equals 0 and y equals 1. Let's say it's right there. So there's our region, and we're rotating this around the what axis? X-axis. So you draw the flip side of it, the reflection. And let's keep the same color here. We have this, and we have... Oh, it's not really the same there. I didn't do a very good job. There and there. And then are we supposed to use shells or washers? Shells. So let's actually pick a different color and do that. So let's say we have this right here. And let's say this right here. So let's go like that. That's not a very good circle, is it? I'm still doing bad with circles today. It's okay. But do you see the cylinder I'm trying to draw nicely and kind of failing it? It's not that bad. Okay, so is this dy or dx? This is definitely dy because you're circling around the x-axis. The thickness is this little tiny part of the y-axis. What's the lowest y value? Well, you can go from -1 to 0, or you can go from 0 to... Yeah, go from 0 to 1. It doesn't really matter, but you can. What goes on the outside? 2 pi. And we need our h of x, and we need our r of x. I don't know why I have that extra one in there. R of x. So what is our... And actually, it's not going to be r of x. What is it going to be? It's going to be in terms of what? Height in terms of y, and r in terms of y. What's the easy one? The radius of the height. Which one do you think? The radius is generally easy. In this case, what is r of y? It's just y. Just the distance from the x-axis to the point. It's right there. So our radius is right here. There's our radius right there. Nice. Integral become, what does it become? 2 pi, the integral from 0 to 1 of y times dy. And is that all in terms of one variable? Yeah, so you get 2 pi, integral from 0 to 1 of y to the what power? 3/2 dy. Now, is that something you can definitely do? Yes, absolutely. So I'm going to change this. So this is the last one you just did. I'm going to change it just a little bit. I'm going to say you are bounded by, let's say, instead of x equals 0, I'm going to make it x equals 1. And you're bounded, and you're rotating around, y equals 1. Yeah, let's make it y equals 1. Around y equals -1. So you're bounded right here. You're bounded by this, this, and this. Those are your bounds, and you're rotating it around y equals -1. Draw me a picture first. Once you have the picture, raise your hand. That does not actually do anything worthwhile. Do this instead. Well, x equals 1/4. That's y equals what? -1, exactly. So she's rotating, and what does she draw there? A shell or a washer? A shell. So that's going to be 2 pi, and it's going to be dx or dy? Dy. So you need the radius in terms of y and the height in terms of y. What's the lower value here? What's the smaller value, and what's the upper value for the limits of integration? The upper one is definitely what? 1, right? The highest value is 1. But what do you have to figure out? What's the lower thing you have to find out? What's the lower? X is equal to 1/4. What's the y value? The y value is 1/16. Yeah, because we squared it. Yeah, you solve for y. What do you do to both sides? You square both sides. So we now know we're going, just to reiterate, we have 2 pi from 1/16 to 1 of the radius in terms of y times the height in terms of y. In this case, what's the radius going to be? What's r of y? What is it? 1.5? The radius is going to be y what? It's going to be y plus 1 or y minus 1? It's going to be y plus 1 because you're not just going to the x-axis, you're going 1 further. And then what's the height going to be? That's the horizontal right here. That's going to be the square root of y what? Did we make the height bigger or smaller by cutting off 1/4? Smaller, so it's going to be the square root of y what? Minus 1/4. So what do we now have? 2 pi from 1/16 to 1 of what? Y plus 1 times the square root of y minus 1/4. A whole bunch changed just because we changed one boundary and the axis of rotation. So actually, it's not a small change. It's a pretty big change. One thing in here. So there should be a squared right there. X squared squared. So the squareds were missing. So yeah, you're kind of you were kind of, oh, there's already a square there, so we're done. So you got to square both of them. Okay. So let's fix that. So then we put the squaring in, the 2 squared and the x squared squared. But what's the problem here? The radius is, you're right, the radius is 2 on the other one, but what's the radius on the other one? The little radius. You have to draw the little radius in here. What is the little radius? It goes from here to there, right? There's your little radius right there. And what is that? That's x squared what? Plus 1. It's x squared plus 1. So what should our integral actually be? Pi 1/4 to 1 of what? 2 squared minus x squared plus 1 what? Squared dx. Let's see if that works. Yeah, pi times a to b, integral from a to b of big R squared minus little r squared d whatever, right? And then so that's for shells, sorry, that's for washers. And then what do we have for shells? 2 pi from a to b of what? Radius times what? Height. D, whatever you're going to do it into. That's shells. So know those two. Put everything away except the pencil.